We've got a telesales operator and we want them to buy a magazine. So X equals the number of magazines bought. And for part A, he chooses a number of people to telephone, suggest a distribution. Well, I suppose it'll be a binomial, with n being the number of people he chooses, and the probability that they buy the magazine is 0.1. Binomial because you can either buy it or not. We've not given n though, but there was that. Part B, on magazine, on Monday he phones 10 people. So X is a binomial 10, 0.1, and we're being asked to find what is the probability that he sells at least 4 magazines. So 4 or more. Grab my calculator, grab my statistics mode of my calculator, distributions, binomial, CD. Lower one is 4, upper isn't 99999 because it's a binomial. The upper end is 10, you can only sell 10 of them. We've got 10 trials, probability 0.1, and that gives me quite a low number there, actually 0.0128 to 3 significant figures. Part C, calculate the least number of people he needs to telephone on Tuesday so that the probability of selling at least 1 magazine on that day is greater than 0.95. Lots to read, lots to think through. There is some direct ways of doing it, but I think what I'll do is I'm going to do a trial and improvement way. That we're trying to find out what this n here is, so that the probability that x is greater than or equal to 1, at least 1 magazine, and we want that to be greater than or equal to 0.95. So I think I think the quickest thing here is simply just to play about. So we want 1. The upper end and the number of trials are going to be the same. Should we guess it's like, clearly we've not got, let's try 20 to start with. Let's have a guess. When n is 20, that wasn't a bad starting guess. We get 0.878, so that's not high enough. So let's change this, let's go to 25. And we're getting better, so n equals 25. Sorry, that was n equals 20. N equals 25 is 0. See, look, this isn't going to take too long. This is probably the quickest way. Let's go to 28. Oh, look, we're nearly there at 28. At 28, I'm 0.9476, 9477 in fact. So at 29, I think this is going to be the one. And I didn't pre-record this. I didn't look at the answers beforehand. I've just taken some guesses. And so that gives us the first value, which is more than 95%. So I've got n is 29 there, just by doing a trial and improvement way of doing it. I'll do D on a separate videos so I can actually chat to you about what another way of doing this would be. Because of course the probability that x is greater than 1, greater than or equal to 1, is basically everything except failing on every single one of them. And failing to sell was 0.9. So look, selling 0.1, failing to sell 0.9, and we want that to the power of n, and we wanted that to be greater than or equal to 0.95. So if I just rearrange that, I can get that we want 0.9 to the power of n to be less than or equal to 0.05. You might not have done logs yet, but this is we want to do for this bit here, the calculator there. All we're going to try and do for this is we want to do mat log base 0.9, 0.05, and that tells us n, is going to have to be greater than or equal to 28.4. And so n, again, actually turns out to be 29. So that's a more algebraic way of doing it if you don't like just trial and error. But if you don't know logs yet, that wouldn't have been possible.